Good day, fellow. Sitsu is back. And if you are new to the channel, please kindly don't forget to subscribe. Today we are going to do the concept of magnetism. Magnetism. Have you ever came across the term magnetism? If no, it implies the phenomenon which is produced by the electric charge in motion. You see, the term electric charge in this context refers to the movement of electrons. We know that electrons, they are negatively charged. Okay, now for the sake of this video, we are going to consider a bar magnet. A bar magnet, we know that a bar magnet has two poles, north pole as well as south pole. Such we say it's a dipole. You see why? Because now it has two poles. See, the bar magnet also produce what? Magnetic field. The bar magnet also produce magnetic fields. Let me try to draw nicely. The bar magnet also produce what? Magnetic field, which always move away from a north pole, towards the south pole. We have magnetic field produced by a magnet in this scenario. Then what do we mean by the term now magnetic field? It's a region of space in which magnetic objects experience a force. You see? Sorry, I hope you can see. Okay, experience a force. What I'm going to do now is I'm going to take two bar magnets. Let me take this one with this one. What I'm going to do, let's make this one north, this one south, this one north, this one south. Have you ever played with magnet? They sometimes attract each other or they sometimes repel each other. Then now today you are going to find out why do magnets attract. Check. Now I have placed these two magnets having two poles which are opposite of one another. Somehow in this case I have two unlike poles. Then let's see now what is going to happen between the two, the north pole together with the south pole. Early on I said to you that the magnetic field always move away from north but towards south. You see, they will move away from north, but towards what now? South. Same applies away from north toward south. Even here, away from north toward south. Then in this case, we get what now? Towards the side, towards. See, then away this side, away like this. You see, in this situation, we get what? Now the attraction of what? Of two magnets. Attraction. They attract now. Two unlike poles, they do what? They attract. You see? Now let us consider a situation whereby now I have two like poles. Let's say if now we have a case like this, whereby now I have, let's say, south together with north, then south here together with north. How then are we going to represent the magnetic field lines in this given magnet? It's so simple. Check. Now I have two like poles. Like poles. Say poles. What is going to happen to these two poles now is that if we have two poles, somehow we know that the magnetic field, they always move towards like this, south. Same applies towards south. Even to this one, they will move towards south, same towards south, then away from north, even this side, away from north. Eventually, what is going to happen now? These two, they are going to repel each other. Why now? Because we get a small gap in between. Do you still remember here we had no gap, you see? But on this one now we have a gap. That gap shows that these two magnets, they do what? They repel each other. See? Then we also have another case whereby now of two like poles. Whereby now I have a north, two north facing each other. How are you going to draw the magnetic field lines around each of these magnets? It's so simple. You apply the same principle, saying now, okay, magnetic field, they move away from north. Same applies to this one. They will move away north towards. It's like this one produce magnetic field lines which moves away, same as this one produce magnetic field lines that moves away from one another. Eventually they will not meet. It's like they act against each other, you see. Then this side will move towards, same towards. Then for such a case, we say now these two magnets, they do what? They repel. Same applies like poles. They repel one another. You see? And I just want to urge you of something, that if let me erase somewhere here. Okay, I just want to urge you that, let's say if I have a magnet like this now, it has North Pole together with South Pole, then somehow I decide to cut it in half. You see, a magnet, you must know that a magnet always exists in dipole phase. You see, dipole, that means it always have what? North and south pole. A magnet always exists like that. You see, it's like if I were to cut this thing in half, say now I have my north this side together, now I have what? My south this side. Just next to, or on this side now, this pole will be now what? Will be our south pole. Then this other half is going to be north pole. You see, magnet always exist in dipole. You see, that means they always have two poles. They will always have two poles. You just need to bear that in mind. And okay, the earth that we live at, it also produces the magnetic field. Then what are the advantages of magnetic field that the earth produces now? Is that on earth, let me say on earth, see, the magnetic field, they protect us, or they protect the earth somehow, us from the solar energy of the sun. You see, the advantage of magnetic field is that they protect us from what? From solar energy. You see, lastly, what I'm going to do is, let's take this bar magnet. Let me take this bar magnet, North Pole, North South Pole, and let me draw fields around. And bear in mind, they should not cross. They should not cross one another. Oops, I don't have much space. They should not cross. Yeah, I've tried. Okay. You know what? See? Then, bear this in mind. I have, let's say, point. Let me draw like this. I have, let's say, point A together with point B. Together with point B. Where do you think between these 2 points is our magnetic field the strongest? Is it A or B? Clearly A. At A, the magnetic field, they are strong. You see, that means somehow the magnetic field, they are stronger, closer to the magnet. The magnetic field are stronger, closer to the magnet, closer to the magnet, you see. But now they are weaker. Let me say they are weaker away from magnet. See, then lastly, what I'm going to do is, we say two unlike poles do what? Attract each other. Somehow this one will exert the force to the right, this one to the left. Then this one will move in that direction with the force F. Same applies this one with the force. Okay, if we were to consider the direction, let's say this one toward the left, then this one toward the left. Then same applies, this one will move towards they will repel each other towards the right, then this one toward the left. Hence we said, when we were defining the magnetic field, we said it's a region of space in which a magnetic object experiences a force. You see, that force is when these two now they do what? Attract. On this one is when these two they do what? Repel. Same applies to this one, they repel. You see, I thank you, fellow, and enjoy.